In this video, we are going to take a look at Chapter 4 of your Ag Economics textbook, and the title of this chapter is Consumer Equilibrium and Market Demand. Here are a few of the key terms that we are going to discuss. You can see we're going to start off by talking about equilibrium, and then we're going to move into demand. We're going to look at the consumer demand curve, the market demand curve, different things that affect the demand curve, and then we'll finish up with consumer surplus. So first we're going to take a look at consumer equilibrium. So if you recall from last week, we looked at the budget line and the indifference curve. Today we're going to put the indifference curve together with the budget line to find the consumer equilibrium. So on this chart over here, let's take a look at this first. We see we have three different indifference curves plotted, and we have a budget line. So similar to what we needed in the previous chapter for the budget line, we are given a price for two goods. So we're given the price for tacos and the price for hamburgers, and we are given a budget. Okay, so given this budget and these two prices, we can say that the consumer equilibrium is at the point where the budget line runs tangent to an indifference curve or meets an indifference curve. So we have multiple definitions of the consumer equilibrium over here. It is the point where the consumer maximizes their satisfaction while adhering to the budget constraint, and it's the point at which the slope of the budget line equals the slope of the indifference curve. That's happening right here, where the budget line is running tangent to one of the indifference curves, or a point on one of the indifference curves. So where those meet up, that is at the combination of 2 hamburgers and 5 tacos. This should actually say combination. So the combination point where consumer maximizes their satisfaction while adhering to the budget constraint. So consumer equilibrium is under these prices and this budget. It's where the consumer purchases 5 tacos and 2 hamburgers. As we saw in the previous slide, where the budget line meets the indifference curve, that's the point of equilibrium. This slide is just telling us that points B and D are outside of the budget line. So anything that is on this side, the right side of the budget line, costs too much money. That's higher than our budget. For example, point B here is at 4 hamburgers and greater than 6 tacos. Well, the hamburgers were $1.25, the tacos were 50 cents, and if we multiplied that out, 4 times 125 is $5.50 times 6 is $3. That's going to be $8, and our budget was only $5. So again, anything to the right exceeds budget. Anything to the left of the budget line, then, as in point C, we have enough money for that because it falls within our budget, because we're only buying a little bit less than 2 hamburgers and then 4 tacos. So the 4 tacos are 50 cents. So that's going to be $2. And then looks like about 1.75 hamburgers at 125. Well, that's going to be less than 250. I don't have a calculator right now. So we're less than 450, and we have $5 to spend, so we're not spending all of our money. And the consumer equilibrium states that we're going to maximize satisfaction while staying within our budget. We can maximize satisfaction by spending a little bit more money to max out our budget there. So anything below is less than the budget, and anything above the budget line is more than the budget. So we looked at where consumer equilibrium exists on a graph, which is where the budget line meets the indifference curve. So that is where the two slopes of those lines are equal to one another. So a way to consider consumer equilibrium in an equation is, so the price of hamburgers over the price of tacos, this is looking at the slope of the budget line at any given point. So when the slope of the budget line equals the slope of the indifference curve, and the slope of the indifference curve is the marginal utility of hamburgers divided by the marginal utilities of tacos. When those two slopes are equal, that's when they're going to be tangent, and that's when consumer equilibrium exists. So this can be interpreted as the point where the rate at which the market is willing to exchange tacos for hamburgers is equal to the rate at which the consumer is willing to exchange tacos for hamburger. So it's where the marginal rate of substitution is equal to the budget line, and it's where these two slopes are equal. We can rearrange this equation just by cross multiplying and dividing to appear as this equation down here, the second one. So we're just flip some numbers around, that's algebra. And so also the marginal utilities of hamburger over the price of hamburger, that ratio, when that equals the marginal utility of tacos over the price of tacos, when these two ratios are equal to one another, we are also at consumer equilibrium. So this probably seems a little fuzzy, but we're going to use this equation in the next slide to answer some questions that you'll see on the quiz. Okay, looking at this example, assume that for a given consumer, the marginal utility of 7-Up is $1.60, the price of 7-Up is $2. Also assume the marginal utility of Coke is $200 and the price of Coke is $3. Okay, so first we need to see at these ratios, are we in equilibrium? So we're going to look at this equation, but we're going to sub some things out here. Instead of hamburgers, we're going to put 7-Up. Instead of tacos, we're going to put Coke. Instead of hamburgers, we're going to put 7-Up. Instead of tacos, we're going to put Coke. Okay, so price of 7-Up is $2. Price of Coke is $3. Marginal utility of 7-Up is $1.60. Marginal utility of Coca-Cola is $200. First question, are we in consumer equilibrium at this point? So if these two ratios equal each other, then we are in consumer equilibrium. So 2 divided by 3 is 0.67. 160 divided by 200 is 0.8. Do those two numbers equal each other? No, they do not. So in order for them to equal each other, so they're not in equilibrium, okay? So the question is, how can we change this side of the equation to get this 0.8 more equal to 0.67, okay? So again, this 160 is the marginal utility of 7-Up. So if we increase the marginal utility of 7-Up, so let's just say we increase that to 200. Now the marginal utility of 7-Up is 200 and the marginal utility of Coke is 200. 200 divided by 200 is 1. Is 1 closer to or farther away from 0.67? Well, it's farther away from. So we definitely don't want to increase the marginal utility of 7-Up. Instead, we likely want to decrease it. So let's say we decrease the marginal utility of 7-Up. I'm going to rewrite this over here. So we have 2/3. We want to make it equal to somehow something over 200. So if we decrease the marginal utility of 7-Up, right now our marginal utility is at 160. So if we make it smaller, let's say we make it 130. Now 130 divided by 200 is 0.65. And then we have 0.67. We got closer, right? We're not exactly right, so we'd have to play with that number a little bit. I do believe if we do 134, that's going to give us our 0.67 that we're looking for. But the point is that we needed to decrease the marginal utility of 7-Up in order to reach consumer equilibrium. Okay, but that's not an option here. Decrease the marginal utility of 7-Up. However, buying more 7-Up inherently decreases the marginal utility of 7-Up because remember, marginal utility decreases as we consume more of a good. So the satisfaction that you gain from one more of that item, as we've talked about earlier in this lessons, as you consume more. So we know we need to decrease the marginal utility of 7-Up, and how we're going to do that is buying more 7-Up. So that is your answer for this practice question. Okay, we have another one that is similar here. I'll get you started on this, but then I'll let you finish it. So assume that a given consumer, the marginal utility of wine is 100 and the price of wine is 60, marginal utility of lobster is 200 and the price of lobster is 100. So again, we're going to make hamburgers wine and make tacos lobster. Make hamburgers wine and make tacos lobster. All right, so first we need to figure out, is this in equilibrium? Well, price of wine is 60. The price of tacos, or not tacos, lobster is 100. The marginal utility of wine is 100. And the marginal utility of lobster is 200. Okay, so 100 divided by 200 is 0.5. 60 divided by 100 is 0.6. So we are not in equilibrium, so it's definitely not number one. We can tell there is sufficient information here. We just got to think a little bit more. So we basically need 0.05 to move closer to 0.06. So again, this is MU of wine. This is marginal utility of lobster. So in order to get 0.5 closer to 0.6, we are going to increase the marginal utility of wine. Okay, so because we need that ratio to be higher. So I don't know, let's see what 120 over 200 does. So 120 divided by 200, that gets us right there, that's a 0.6. So we need to increase the marginal utility of wine. How do we increase the MU, marginal utility of wine? Do we buy more wine? Do we buy less wine? Well, again, to decrease the marginal utility, you buy more. So we would actually want to buy less. So in this case, we want to buy less wine. However, that is not an option. To buy less wine is not an option. So getting 0.05 to get closer to 0.6, we're going to have to go another route. So we're going to keep 100 MU as the marginal utility for wine. We can also change the bottom number to get closer to 0.06, right? So the bottom number, to get closer to 0.06, we probably need to decrease that. So if we now go down to 180, 100 divided by 180, that increases us a little bit. That equals 0.55. So we know we're going to have to increase that. We don't have to figure out the exact amount, but for fun, maybe let's try 100 divided by 170 is 0.58. Okay, so instead of buying less wine, if we want to decrease the marginal utility of lobster, which is what we just did here, and we got closer to our 0.6, and we can go a little bit further and we can decrease even more, and then we'll be at 0.6. But the point is, we want to decrease the marginal utility of lobster here on the bottom, and in order to decrease the marginal utility of lobster, do you need to buy more lobster or buy less lobster? I'm going to leave that to you to answer. So the consumer equilibrium can actually change. So in that previous example, we had a particular quantity of hamburgers and a particular quantity of tacos that we found at the point where the indifference curve met the budget line. This point can change, and it can change as a result of the change in price of either of the products, so of hamburgers or tacos, and it can also change in a result of a change in the income of the consumer, which would be a shift in the budget line. Maybe the budget line shifts up, maybe the budget line shifts down. So let's take a look at how some of these things can happen. So to begin, this is another snapshot of the budget line that we were working with a couple slides ago. So this is the original equilibrium point where we have 2 hamburgers, 5 tacos. Now we are going to change the price of hamburgers in the next slide, and let's see what that does to our budget line. So in this slide, we've increased the price, we've decreased the price of hamburgers. So they've become cheaper, they've become $1. Now our two extreme points, or one extreme point has changed. We can now, because hamburgers are only $1, if we spent all of our money on those hamburgers, $5 divided by $1 is 5, so our extreme point is at 5. So our budget line changed. Our budget line moved from the left to the right, which means now that our budget line is falling tangent at a different point than it was originally tangent at. So it was originally tangent at A when hamburgers were $1.25, but now that hamburgers are $1, it's tangent here at point B. So then we got to follow that tangent line down and see, okay, what is our new consumer equilibrium? Our new consumer equilibrium is at the point where the consumer is purchasing 3 hamburgers instead of 2, but our tacos our tacos decreased. So our tacos went from 5 to 4. So that's our new equilibrium as a result of the budget change. In this third example, our price continues to change, but this time our hamburger price increased to $5. So if there's one hamburger for $5 and we only have $5, we can only buy one hamburger. With that, so our budget line shifted to the left, which means that our new equilibrium is now tangent to a different indifference curve, because if you recall, there's multiple indifference curves, and the further to the right the indifference curves, the more desirable it is. However, none of these points fall within our budget anymore. So we are falling on this line of where C is on the indifference curve, and we can see that the consumer equilibrium is now about a half of hamburger, and I would say 5.2 tacos, maybe, approximately. So that is now our consumer equilibrium. So you can see that the equilibrium shifts according to changes in prices of the products that we are looking at. Okay, so if we were to, we have all three of the budget lines on here for each of the different varying prices of hamburgers. What these points show us are the beginning of a demand curve. Consumer demand schedule, consumer demand curve, similar things. We can take these points and change them into a demand curve for hamburgers. So a demand curve has quantity of one item on the x-axis, and it has price of that same item on the y-axis. So we can see here, if we took these exact points, this first point here is C. If the price is $5, because recall that C, the price was $5, then we demand only one burger. If the price is $1.25, so that's going to be down here, then we demand, what does that one fall? That one was at 2. 2, and if the price is $1, then we demand 3. So we start to see our demand curve here. Okay, and they did the same thing. It was $5, demanded a half a burger, $1.25 to $1.03. So they just did exactly what we did. They had one more data point, $6 they added, they were going to demand 0. So we can take that information from the various equilibriums at various price points of particular goods to create a demand curve. The plots, as the price of the good changes, the plots change, or the points change on the plot, and we can see that here. So that's where we get the demand curve from. Now, what we just saw was a consumer demand of an individual person. So there's a difference between consumer demand and market demand. Consumer demand is if we are looking at the desires at various prices of a particular product for one person. In this case, we have what Paula is interested in buying. And then this second curve, we have what Beth is interested in buying. And then C, we have what Beth and Paula together are interested in buying. So we can see that if the price of hamburgers are $1.50, because we have price of hamburgers across here, Paula is willing to buy 2 hamburgers at that price. And if the price is $1.50, Beth is willing to buy 1 hamburger at that price. That means if Beth and Paula were the only 2 people in the entire market of buying hamburgers, the market would be at 3 hamburgers for that $1.50 price. 2 plus 1 equals 3. So obviously there's more than 2 people in the market for purchasing hamburgers, but that just sort of simplifies how we add up everybody's demands to figure out what the market demand is. So the market demand is a bigger picture of all consumers' needs. This problem is going to allow us to practice the difference between consumer demand and market demand. So we have 2 ladies here who have different budgets and who have different desires, and we're going to look at these curves to answer these questions. So it says Betty and Wilma wish to buy t-shirts and shoes. Betty has a budget of $600. Wilma has a budget of $1,200. Using the indifference curves below, so remember these are the indifference curves and these are the budget lines, determine the prices for t-shirts and shoes. Okay, so we have their budget stays the same, but we have different budget lines here because we have varying prices going on. So let's figure this out. So first, we need to determine the prices for t-shirts and shoes. So let's start with that. So this first budget line, I'm going to erase some of this. So this first budget line for Wilma right here has a specific price for shoes and has a specific price for t-shirts. Okay. How we're going to figure out how much t-shirts cost at on this budget line is, well, she has a budget of $1,200, but if she spent all of her $1,200 on t-shirts, she could buy 80 of them. So to figure out the price at that point, we're going to take 1,200 divided by 80. So 1,200 divided by 80 is 15. So that means that t-shirts cost $15 on this budget line here. Okay, so t-shirts are $15. So let's record that under Wilma's information under one price of the t-shirts. Okay, so when t-shirts cost $15, Wilma actually desires to purchase 60 of them because that is where her indifference curve meets the budget line. So when they cost 15, because that's the budget line that they cost 15, she wants to buy 60 of them. So Wilma will buy, when the price of t-shirts is $15, she will buy 60 t-shirts. Okay. Now we need to figure out what the price of shoes are. So if she were to spend all of her $1,200 on shoes, she would be able to buy 40 shoes. So 1,200 divided by 40 is $30. So that is the price of shoes on that budget line. So we're going to write that there. Also on that budget line, the number of shoes that she would want to buy is 10, okay, because that is where her indifference curve meets her budget line. So pairs of shoes that she would buy is 10. All right, so I have one budget line figured out for Wilma. So let's go to her second one. Let's clear some space here. Okay. So on this second budget line that we have for Wilma, we see that if she were to spend all of her $1,200 on t-shirts, she would be able to buy 40 of them. Again, 1,200 divided by 40 is 30, so that would mean the t-shirts would cost $30. So when t-shirts cost $30, Wilma is interested in purchasing 20 t-shirts because that's where her indifference curve meets the budget line. So quantity of t-shirts is going to be 20. When okay, now if we look at the shoes on that same budget line, the shoes didn't actually change, right? They're still there at 40. So again, 1,200 divided by 40, the shoes are still going to cost $30, but in this situation, because the price of t-shirts changed, she now desires 20 pairs of shoes. Okay, so we have Wilma taken care of, so let's move over here to Betty. So we have this first budget line to look at, Betty's first budget line. So her budget's different. So she has $600. So if she spent all of her $600 on t-shirts, she would be able to buy 40 of them. 600 divided by 40 is going to give us the price of the t-shirts at that point. 600 divided by 40 is, okay, 15. So price of t-shirts for Betty, 15. At that point, she, let's look at her indifference curve, wants to buy 30 t-shirts. So when the price of t-shirts is 15, she wants to buy 30. And shoes, okay, probably guess what this is going to be, 600 divided by 20. So the shoes are $30 here. When shoes are $30, Betty wants to buy 5 pairs of shoes. Looking at the second budget line, when we got to figure out the price of t-shirts at this budget line. So we're going to do 600 divided by 20. That's going to give us 30. Okay, so price of shoes is not changing here. And, or sorry, that was t-shirts. We're going to put 30 over there. 600 divided by 20. So the price of t-shirts at this point is 30. And how many does she want at that point? Well, she would buy 10. Okay. And then we have shoes. The price is not changing. So we have shoes that are $30. And at that combination price for t-shirts and shoes, Betty wants 10 pairs of shoes. Okay, so we have determined the prices for t-shirts and shoes. The shoes never change. They're only at $30, and the price of t-shirts for one of the budget lines is $15, and for the other budget line is $30. Next question, for which commodity can you derive a demand curve? Well, you can only derive a demand curve when you have multiple prices for the same item, because the idea is behind a demand curve, what will happen to the demand when we raise or lower a price. So we cannot derive a demand curve for shoes because the shoe price doesn't change. So we can derive a demand curve for t-shirts. Okay, now we're going to do that. We're going to derive a consumer demand curve for Betty, a consumer demand curve for Wilma, and then we're going to add their demand curves together to make the market demand curve. So let's put demand curves, we gotta label them as price and quantity. So let's erase a little bit of information here. All right, so price is gonna go along this, quantity is gonna go here, price, quantity, price, quantity. All right, so we'll start with Betty. So the price, obviously we have 15, and then we have 30. That's what we will also have on all of them. 15 and then 30, 15 and 30. The quantity for Betty, so when the price of t-shirts is 15, she wants, okay, so we gotta go, let's go 10, 20, 30 across here. So when the price of t-shirts is $15, Betty wants 30 of them. So that's where our first plot is going to go. When the price of t-shirts is $30, Betty only wants 10 of them. So that is Betty's demand curve, which we can see as we decrease price, we increase quantity demanded. For Wilma, she has some higher quantity numbers here. So let's go 10, 30, 50, 70. Just to provide us enough. So when the price of t-shirts is 15, Wilma demands 60. So that would probably be in between there. And when the price of t-shirts is 30, Wilma demands 20. So that's going to be right in between there. So that is Wilma's demand curve. Finally, we need to add these two together in order to create the market demand. So we still have the prices of $15 and $30, but now we need to add how many are demanded at the price of $15 together. So at $15, Betty demands 30 and Wilma demands 60. So 30 plus 60 equals 90. So now the market demand, we're going to put 90 over here, is 90 t-shirts when the price is $15. When the price is $30 a t-shirt, Betty demands 10 and Wilma demands 20. So the market demand is 30. So that would be the market demand curve. That was a lot of work to get to the final, but hopefully that will give you what you need for the problem for one of your problems at the end of the chapter. Okay, thinking about the demand curve, price and quantity and how much is demanded at a certain price, the demand curve can change under 3 circumstances. Actually under 4, but we're going to talk about this last one later. So when we talk about a demand curve changing, we are talking about it taking a complete shift to the right or a complete shift to the left. Okay. So things that can cause the demand curve to change is if a person's income changes. So if all of a sudden a person was making $40,000 a year and now they're making $60,000 a year, they may demand more of a product. Okay, so their demand may they may demand more of a product at a given price, so their demand may increase. Price of other goods can change. So the demand for Coca-Cola could decrease if the price of Pepsi decreases. Because if the price of Pepsi decreases, more people are going to buy Pepsi and less people are going to buy Coke. Okay. Also the price of complement goods, so things that you eat together. So chips and salsa, if the price of salsa decreases, it's likely that the demand for chips will increase. Okay. And then finally, people's tastes and preferences change over time. Maybe new research comes out that blueberries are the best thing in the world for you, so the demand for blueberries will increase. Okay. So those are the 3 things that can cause a change in demand. Now, we can also move along the demand curve. Basically, we can move from here down to here if the price of the good at hand changes, but that's a little bit different. So these are the same things that influence equilibrium also influence the demand curve. We're going to talk about each of these individually as we go. So to start, we're going to look at income changing. So how exactly the income affects the demand curve depends on whether the good that we are discussing is a normal good or an inferior good. So if it is a normal good, let's define that quick. A normal good, consumption of a normal good increases with an income increasing. So for example, something that if you made more money, you would buy more of, me, that would be maybe Starbucks coffee. So if I made more money, I would buy more Starbucks coffee. So that to me would be a normal good. And a decrease in income will cause a decrease in demand. So the less money I make, the less Starbucks I'm going to buy. An inferior good is the opposite of that. With an increase in income, people tend to buy less of an inferior good. A good example of this is ramen noodles. Generally, people buy more ramen noodles when they have less money, and they buy less ramen noodles when they have more money. So we can determine if a good is a normal good or an inferior good by tracking its demand across various budget lines. So what we have here are 3 different budget lines. With 3 different equilibriums, point A, point B, and point C. So let's figure out how consumer demand of hamburgers and tacos is changed with increasing and decreasing budget line. And also remember, if a budget line increases, that also means the income has increased. So sometimes I'll use the words budget and income synonymously. So let's look at income or equilibrium point A. So at equilibrium point A, the demand is 2 hamburgers and 5 tacos. And the income at line A is $5. At equilibrium B, just to be able to see that a little bit better, 3 hamburgers and 5.5 tacos. And the income at that level is $6. And then finally at C, the demand is 5 burgers and 4 tacos, and the income there is $8. So if, again, a normal good means that as income, an increase in income results in an increase in demand. So our income is increasing here. We're going from $5 to $6 to $8. Are hamburgers a normal good? Did the demand go up? Well, we went, as our income went from 5 to 6 to 8, we went from demand to 2 to 3 and then to 5. So as our income rises, our demand for hamburgers are rising, so it is a normal good because demand is rising with income. are tacos a normal or inferior good? Well, we begin to go up. First we go up 5 to 5.5, so it did go up a little bit, but then we go back, or then we go down to 4. So I would take two answers on this. I would say inferior because demand ultimately decreases as income increases. Or you could say that from points A to B, it's a normal good because demand increases from 5 to 5.5, and then from B to C, it's a inferior good because demand drops from 5.5 to 4. So I'd take either one of those answers. Now, we can answer the question that's being asked here with the information in this chart, but sometimes economists take it a step further and they put this information on a graph called an Engel curve. I just erased all that information now. But where they would graph the quantity with the income, and if you see the quantity increasing as the income increases, that's going to be a normal good. But if you see the quantity, like this, for example, the tacos, the quantity was going to increase for a little bit, then it was going to decrease. So that's what that graph would look like, quantity and income. And then sometimes you would see the quantity decrease as the income decreases. Oops, I'm sorry, I said that wrong. The quantity increases as the income decreases. So that would be an inferior good. This is the exact curves that I was drawing, the Engel curves. So if you wanted to put your data into this chart for the quantity of burgers and tacos, you would see that it directly translates to that Engel curve, which just more easily allows us to see if the good is a normal or an inferior good. As was stated, a change in income can cause a change in demand, and what determines whether that change will cause the demand curve to shift to the right or cause the demand curve to shift to the left has to do with whether that good is a normal good or an inferior good. So if I assume that Starbucks coffee is a normal good, what will happen to the demand curve if income is increased? I'll give you a minute to think about that. What's basically going to happen is that the demand curve will shift to the right. Why this is because at a given price, let's say Starbucks costs me $5 and my income increases. Let's say at $5 per cup, I was maybe willing to buy 2 cups per month. I'm going to say this is quantity per month, 2 cups per month. But if my income increases and nothing else changes, the price of the coffee is still $5, I am now willing to buy, my demand curve shifts over, I follow this demand curve now, and I am now willing to buy 4 cups per month. So if something is a normal good, a increase in income will shift the demand curve to the right. Other things can change the demand curve. One, we're going to look at how the price of other goods change the demand curve. Other goods can be substitute goods or complement goods. So a substitute good is just what it sounds like. It's a good that is consumed or purchased instead of the good at hand that we're talking about. So if we're trying to look at demand curves for Pepsi, Coke is an example of a substitute good. Something that generally people would choose one or the other, but not both. A complement good is something that people generally purchase together. So the example that I have here is chips and salsa. So generally you would not buy salsa without chips, and that's why we would say that salsa is a complement good to chips. And then sometimes there are independent goods. We're not going to look too much at those because they do not influence or change the demand curve or shift the demand curve because they're unrelated. So the two that we're going to look at are substitute and complement goods. So how do these substitute goods influence the demand curve? Well, let's use Coke and Pepsi example here. So if this is the demand curve over here for Pepsi, and let's say Pepsi is $5 per pack, and Coke just raised their prices to $10 per pack. Because the substitute good increased their price, people who were buying Coke might now buy more Pepsi. So the market demand for Pepsi shifts to the right. When the demand shifts to the right, a higher quantity, so we got quantities increasing across the bottom, is desired at the same price than was desired previously before Coke raised their prices. So we jumped from a quantity of A to C. The price of Pepsi stayed exactly the same, but the price of Coke increased, causing a shift in the demand curve. The opposite would happen if the price of Coke decreased. So now let's say all of a sudden the price of Coke decreased to $2. Now we would have a shift to the left, and less people would be interested in buying that $5 Pepsi because they can buy Coke for $2. Okay, so, and that's what's going on in this picture down here. A complement good works in the opposite way. If the price of the complement good goes up, people will buy less of the good at hand. So for example, if we're talking about chips and salsa, the price of chips goes up, people will buy less salsa at the given price of salsa. So the curve will shift to the left. Vice versa, if the complement good price decreases, so if price of chips decrease, everybody might go out and buy chips, or might go out and buy salsa because chips are so cheap, so let's get salsa with all these chips. So in that case, the demand curve will shift to the right. The important point to remember here is that the price of the good at hand is not changing. And when I say good at hand, the good that we're talking about. So in both of these examples, we're talking about the salsa. But the price of the good at hand is not changing. We're going to A to C, and the price is remaining the same. The price of the complement and supplement goods are changing, and that's what's causing these changes in demand. Okay, a third reason that we can have a change in demand is that consumer preferences and price and tastes change. So consumer tastes and preferences change. Some examples of consumer preferences or factors that influence consumer preferences are the composition of the population, attitudes towards nutrition and health, attitude towards food safety, advertising, and lifestyles. So these are all non-economic things, so they have nothing to do with prices going up and down. They have to do something with culture, attitude, or lifestyle. A few examples. If there's a change in the composition of the population, so in recent history in the U.S., our racial and ethnic composition has changed. Specifically, for example, we have an increased number of Hispanic and Asian Americans in our population. Therefore, demand for Mexican food, Asian food has increased. So that has caused a shift in the demand to the right. Price of that food has not changed, causing a change in demand. It's this outside factor. Okay, similar to that change, there's these other outside changes. So, and in regards to nutrition and health, let's say that historically information has been released linking tobacco to cancer. So that health report, that science, that research has caused for a change in demand for tobacco. So now there is a shift to the left. Demand has decreased for tobacco because of this outside research finding. Similarly, there has been in 2018, there was an outbreak of E. coli in romaine lettuce that also caused a shift to the left. Again, these are all outside factors that cause these change in demands. So just to review really quickly, a shift in the right means that people are willing to buy more of a product at a given price. The price stays the same as a result of some outside factor, whether it's a change in income, whether it's a change in taste and preferences, or whether it's a change in a complement or supplement price. Shift to the left means that consumers are willing to pay less or to buy less of a particular good at a given price than they originally were willing to, again, for the same reasons that we discussed that could cause shifts to the right. Okay, finally, a demand curve can change. So all of the ones that we've talked about thus far have been outside factors that have nothing to do with the good at hand. This last example, we're going to talk about what happens if the price of the good at hand changes. What we have when the price of the good at hand changes is we have a change in quantity demanded. And the textbook really distinguishes and has multiple test questions on the difference between the change in quantity demanded versus a change in demand. All of the examples that we previously did that shift the demand curve to the right or to the left are all change in demands. So the price is remaining constant, but due to some outside factor, people are willing to buy more at the same price or willing to buy less at the same price. A change in quantity demanded is simply a result of a price change of the good at hand. So I'm underlining that in green. Anytime there is, I'll highlight it actually. Simply a movement along the demand curve up or down due to a price change. So if steaks go from $6 a pound to $2 a pound, the quantity demanded for steaks is gonna increase as long as it's a normal good. And that's just movement along a demand curve. That is not a shift. Okay, so there's a big difference there. Change in quantity demanded versus change in demand. Okay, and what I was just giving an example of with the steaks before, we have this term we use called law of demand, and it applies to anything that is a normal good, and it just states that as the price of a good increases, so here the price is increasing, the demand will decrease, and vice versa. As the price of a good decreases, the demand will increase. Okay, our final slide here, the concept of consumer surplus. So sometimes people pay less for goods than they are actually willing to pay. And the difference between what a consumer is willing to pay and what they actually pay is the consumer surplus. So businesses want to minimize that consumer surplus because they obviously want to charge customers as much as they possibly want to pay. And consumers obviously are really happy when they get things for less than they were willing to pay. So if I was willing to pay $70 for a new pair of tennis shoes and I found them on sale for $40, I'm actually really happy. And my consumer surplus there was $30 that I didn't spend. The difference between 70 and 40, I didn't spend $30 that I was willing to spend. So on a demand curve, you can identify and calculate consumer surplus pretty easily. So we're going to actually do this problem. This is another problem in your text, and we'll go through it right now. So clearly label the consumer surplus associated with a market price of $6 using letters on the graph from the previous page. Don't worry about the from the previous page, using letters on the graph. Okay, so they're saying we pay $6 for this good. If we pay $6, this is our budget line. Recall, we paid $6, so we purchased 3 of this item. So what we paid is the area of this rectangle, right? We bought 3 of them for $6 a piece. So what we paid was $18. What we were willing to pay, well, at $8, we were willing to pay 0, or we were willing to buy 0. But we would have bought, if we divide this into 3 sections here, we would have bought 1 for about, that looks like it's about maybe $7.50. We would have bought a second one for about $7. And our third one is where we were only willing to spend $6, but we actually got 3 of them for $6. So when you're calculating the surplus, there's all these little marks in here too. We would have been bought a half of one for $7.75, etc. The point is, the consumer surplus is this area of this triangle that falls below the demand curve and above the market price. So our market price is $6. I'm sorry, this was the demand curve, not the budget. So, and below the demand curve is this purple triangle right here. So how do we find the area of that? well, I gotta probably erase some of this. But the area of that, well, we know the area of a triangle equals base times height divided by 2. Our base is 3. Our height is 6 to 8, so 2 divided by 2. So we have 6 divided by 2 is 3. So in this case, our consumer surplus is $3. Okay, I went ahead of myself though. Clearly label the consumer surplus associated with the market price at $6. So A is A, B, D. So it's triangle ABD. B is asking us to suppose the market price decreases to $4. Are consumers better off or worse off because of the decrease in market price? Well, at $4, our consumer surplus just increased. And a high consumer surplus means that you spent even less money than you were willing to spend. So consumers are better off when consumer surplus is high. So this would be better. And it says using the letters label the change in consumer surplus. Well, we basically went from this small triangle to this large triangle. The change is this addition of the green quadrilateral there. So if we are labeling the change is going to be points B, D, C, E. And you can just write that, and that's fine. Calculate the dollar amount of the consumer surplus in A. We already did that over here. That was 3. Be careful of your units of measurement. There might be a D on the other side of this page. Maybe there is, maybe there isn't. I don't recall. But if they ask you to calculate the change, you're just going to have to find this area here. So first you'd find the square, which 4 to 6 is 2. So you have 2 times 0 to 3 is 3. So this is $6. And then we have 3 to 6. So the base is 3 there. Times 2 is 6. This is another 3. So this additional surplus is $9. Okay, so that was chapter 4. Quick review, we talked about the equilibrium point, we talked about consumer demand, market demand, normal goods, inferior goods, complement goods, substitute goods, the law of demand, and consumer surplus. So if you have any questions, as always, please feel free to contact me, and good luck with the problems and the quizzes this week. Thank you.